Thrombin induces the release of von Willebrand factor and causes the hyperpermeabilization of your vessels. Histamine induces the release of von Willebrand factor and causes the hyperpermeabilization of your vessels. So do they induce the same signaling? Well, let's find out. So for histamine, no one had actually really looked at an unbiased report of its signaling event in endothelial cells. So with the help of phosphoproteomics, this is the complete kinase signaling network after histamine stimulation. And some of these phosphorylated proteins are MAPK1 and 3, STAT3, and for example this catenin delta that's completely dephosphorylated after histamine stimulation. So the thrombin response has actually been fairly well studied in endothelial cells. However, thrombin signals to the PAR receptor, and there's 4 PAR receptors: PAR1, PAR2, PAR3 and PAR4. So the signaling to PAR1 is exactly as we expected, and we already described previously. Signaling to PAR2 is almost exactly identical to PAR1, but to a much lower amplitude. However, for PAR3 and PAR4, they induced no signaling events in our endothelial cells, while the same peptides did in platelets, suggesting that in this experimental setting, all signaling goes to PAR1 and PAR2. So then the question that obviously remains is, are these two signaling networks the same or are they different? And well, in very broad strokes, they are very similar. They induce the same kinases, they have a whole range of tight junction proteins that they affect, and most differences were more an amplitude difference. However, there are some uniquely regulated phosphosites, like on PKD1, on PAC2, and here on ROC2. So one of the differences, the key difference we know between thrombin and histamine is their effect on the endothelial monolayer in vitro. So where thrombin induces a massive reduction or disruption of this monolayer, even forming holes in the monolayer, histamine is sort of the reversed reaction. It actually causes an increase in the barrier function. It's almost like these tight junctions are tightening on themselves. Then we wondered whether these 3 differentially regulated phosphosites underlie these differences in effect on the barrier function. So we got inhibitors, did the experiments, and well, we couldn't really see any differences. So still, we don't know what exactly underlies the differences in the effect on barrier function of histamine and thrombin. So there you have it, a quick rundown of phospho signaling in the endothelial cell after thrombin stimulation and histamine stimulation. I hope you have learned something new, or at the very least enjoyed yourself. For now, take care of yourself, take care of each other, and have a wonderful day.